Hi everyone. Today we'll look at SQL, data manipulation languages. Assuming that we have already database created, tables created, and data populated according to the table description. That is a data definition language, DDL. So using DDL, we created the database. Today we'll look at data manipulation languages. Typical format of data manipulation language is a select from where clause. All right. Before we do the select from where clause, we'll do one more DML, which is a view creation. View creation. View is very, very important in databases. Remember that we have tables created. Tables explicitly created is called base tables. So we have a base tables like course, enroll, and student. Based upon the base tables, for the purpose of the user models, we need to serve users' request. Some user may be interested in the course list taught by whatever, okay? Or we could do, if that is a payrolls or registrars. Well, each users may have different request. If it is the case of payroll, then they want to see, for example, in this particular university database, who receives what type of payrolls, what instructors receives how much. If the registrar's office may be interested in who could be in the dean's list if their GPA is over whatever the criteria. And also dean's office may be interested in some of the probation list. Students whose GPA is lower than 2.0 or 2.5. All right. If that is particularly for graduate program, then anybody who receives more than 2 C's, the grade C's from graduate courses, then will have the probation. That type of things. So there may be various different the user models available. In this particular example, based upon those 3 base tables, we want to create the courses taught by John. Okay, so well, anyway, in order to do that, we have to get into this is a terminal. Okay, my SQL running on my MacBook. Usually mySQL is enabled. It's not enabled. It's disabled by default. So I want to start. All right, so database is restarted. Then I can access my mySQL. That is in USL local mySQL, if I remember correctly. And then there is a bin directory, binary directory, and then I want to do mySQL. and minus user root, and then minus p. I want to access my database as root using password credentials. All right, so show databases, then I have registrars database. So use registrar. Show tables. I have those tables, and select start from course. Then I have 2 courses taught by John. I want to create a view. So create view, and then we name it courses taught by John as, and then we can do select start from course where the instructor is John, and I need to close the parenthesis, and if I hit enter, it's not going to be executed until I put semicolon. All right, so how can I use that views? That is very similar to the way that we do here the typical SQL statements. Okay, so instead of select star from course, I could do select star from courses taught by John. Then we could see only this. Okay, so this is the view. This is base table. All right, view is very, very convenient for you to build application modules. All right, and also view is convenient that you do not need to recreate. You do not need to create DML statements. DML statements already defined in this way. Okay, this is a DML statement, right? We do not need to do this every time that we want to access. There's a convenient. There are 2 ways of running views, depending upon the applications. View materializations or view specifications. This is a specification only, right? We specify in this way. And it gives me the answer only when I do this select star from this. This is typically view specifications. For some other situation or reason, then you may build this the SQL result, and then when user requests any part of this view result, then you can simply return from this result. That is very, very convenient, particularly this view specifications is very costly. To perform this, execution of this view takes longer. There's a very, very cost expensive query statement. Then while actively your database is serving user request, this type of cost expensive SQL statements may consume your resources. It may affect the computation performance of other requests. In that case, you have to cook this query result in advance. Of course, it is very, very efficient when the database may not be changed often. For example, this base table course may not be updated dynamically, right? Once it is defined, then during semester, it may last unchanged. That type of things needs to be created as a view. So the reason that we need to view creation is not only the specification, but also improve the computation. Okay, there is one condition. The condition is if the base table is not dynamically updated. All right, so next one is, okay, so we'll practice some of the SQL statements. So first thing that we need to do is to list who takes what course. Who takes what course? Remember that we have three tables. Show tables. If I want to see who takes, if it's a CRN, then we may simply use student and enroll. Student table has CWID, name, and major. And enroll table has CWID and CRN. These two base tables can be joined based upon CWID because the CWID is common in both tables. So our SQL expression needs to be including the condition where CWID in students is the same as CWID in enroll. Unless otherwise, if we do not put any join condition, what happens? It may match all possible combinations. Let's say if we have 4 rows of students and 5 rows of enroll, then all possible combinations between students and enroll gives me 20 rows. Because 4 rows here, 5 rows here, 4 times 5 equals 20. Okay, 20 rows are returned. But that's not what we want, right? We want to see who explicitly takes what course. For example, 1, 2, 3, Adam takes CRN number 111 and 525. And Peter 1 to 5 takes 525. And David 133 CWID never takes any course. Chris 135 takes 525. Something like that, right? That's what we want to see here. So what should we do? In that case, select and then student name and CRN from student and enroll, where CWID of student. Remember, they are the same name. If we do not, we need to explicitly here say which is CWID in the table student or in enroll. To explicitly specify the location, then we need to put here either here student.cwid, or you simply say s.cwid, and s that comes from, that alias comes from students, and enroll that comes from there. So we need to put here s.cwid is the same as e.cwid. And also here CRN, then some DBMS may take it because the name is not ambiguous here, and CRN is not ambiguous, may be able to see where it comes from. So it takes as is. So we'll see. MySQL takes it. If MySQL does not take it, then we need to put here name comes from student, so s.name. CRN comes from enroll, so e.crn. We can fix it that way. See what happens. Hit enter. Oh, so MySQL takes care whether the attributes are defined identically in over the course of the tables. So in this case, this returns, right? What if I don't want to see this as CRN, but I want to see the course title. But course title is not available here. Course title is not available here, student or enroll. Course title is only available in the course, right? So we need to include one more base table here. So course and alias C, and then C has a title. So rather than CRN, I want to put here title. Let's see here. Course has a title, so I want to show the title. Because we have one more, we have three tables joined together. So at least we need to have two or more join conditions. This join condition is a condition specified over student and enroll. So these two tables are joined, okay, reasonably, not arbitrarily or possible combinations. Similarly, enroll and course, these two tables share the same attribute, which is a CRN. Enroll has a CRN here, and course has a CRN there. So we need to see which one is what, right? So this condition now say and enroll CRN is the same as course dot CRN. So CRN can be specified. I want to select only the rows if those two values are the same. All right, so hit enter. Then I could see Adam takes coding, Adam takes database, Peter takes database, Chris takes database, Peter takes defense. I want to go back the Cartesian products are based upon this. What if we do not put any of these conditions? No join conditions. Okay, then as I said, I will receive all possible combinations, right? To compare with that, I want to create one more shell. Basic. Okay. And I want to have here USR local mySQL minus u root minus p no such files local bin bin. Okay. No, not instead of cd, we need to put here use. Okay. And I want to put select name title from student enroll course and hit enter. Then this guy will return Cartesian products. I want to now compare the case that we have this join condition and the case that we do not have. Then we have this many. Let me see if we can do. All right. Okay, so I'm trying to show to you if we do not have a join condition, then this gives me all kinds of the matches. The realistic the result could be, for example, Adam takes coding and databases, Peter takes database and defense, and Chris takes database. Only 5 rows are the realistic, but without having this join conditions, then we will have these many things. So what this join condition could do, for example, s.cwid and e. That, I want to show let's do star. Okay, so what happens here, CWID name and major, this first 3 columns are from student, and then next 2 columns from enroll, and next 4 columns from the course. So here s.cwid and e.cwid. Here we have CWID. This is student CWID. This is enroll CWID. If we see here the first row, student CWID is 1 to 3, and enroll CWID is 1 to 5. They are not the same. So this first row is not real the instance. But if we see the second row, that is a real instance. Up to this point, we do not know yet. For example, CWID Peter in cyber, and CWID Peter takes CRN 550. So Peter takes 550. I do not know. 550 is maybe the defense, right? So 550. This is the CRN of enrollment. But if we look here, another CRN, we have CRN here, that is a CRN, right? This CRN says 550, but this CRN says 111. They're not the same, right? So we need to filter that out. S.CWID and E.CWID should be the same, and E.CRN and C.CRN, CRN comes from two different tables, so should be the same. Like here, CRN 550 and CRN 111, they are not the same, right? Only they are the same, both CWID here and CWID there, and CRN here and CRN over there. So what could be the case? Then let's say 1, 2, 3, 1, 2, 3, maybe this. See here, this rows. Adam in cyber security, CWID is 1, 2, 3. And the very same CWID takes course 111, which is coding, whose CRN is 111. So 111 here and 111 there, they are the same. 1, 2, 3 here and 1, 2, 3, they are the same. Two join conditions matched. If those two join conditions are satisfied, then that is the thing that we filter. That is the answer. That is a part of the answer. So, for example, Adam takes coding. See here, first thing that we have in this result, Adam takes coding. That comes from this. Okay, so without this where clause, it gives me Cartesian products. Therefore, if we have a where clause, in the where clause where there is a join conditions, this is not the conditions, the case that we want to see, hey, the instructor's name is John. That is a specific, the query dependent condition, but this is not query dependent condition. This is only join condition. Okay, that join condition is not given, but should be specified by you. The query writer should include it. If that join condition is not included, then you don't get the reasonable result, but Cartesian products. All right, let's move further. All right, so we did that. List who teaches what students. So this is very similar to this, who teaches what students. Then teacher has the instructor here, so we put instructor, and then we need to have a student's name. I think this is it, right? So right. So if we hit enter, instructor. Instructor is not unknown column. INSTLUCTOR. Maybe that is the case. Instructor comes from where? Instructor comes from the course. Oh, wait a minute. Oh yeah, I need to put this. An instructor here. Previously, I used only the student and enroll, two tables. I need to use 3 tables: student, enroll, and course. All right. Then I have here John teaches Adam. John teaches 2 times Adams. John teaches Peter and Chris, and Osman teaches Peter. To show only one time, because Adam is John and Adam together duplicated. If you want to see only unique records, then you need to put here unique or distinct. So in this case, distinct. So if you put distinct, then these first and second row, they are duplicated, but we display only once. That's what distinct can say. All right, the other ones, list each student with his or her total credits registered. Total credit registered. Credits here, right? And list here is students. So who, student name here and credit there. Course and students are not directly related, but indirectly through enroll. So we need to have 3 tables to be involved. 3 tables, students and enroll course. And then we want to see how many courses how many credits are registered. So we want to put here name and credit. Credit comes from course, name comes from students. Okay, credit. So if we hit enter, then we will have here Adam has 3 credits. Adam has 3 credits again. Peter has 3 credits. Chris has 3 credits. Peter has 3 credits. The issue here, can we sum this? For example, because this is both Adam, I want to show only one Adam, but I want to sum the credits for the case of Adam and also for the case of Peter here. So how can we aggregate those numbers? There are aggregate function available in mySQL. What aggregation function can do is there are multiple input, but only one output. For multiple input data, we can return only one output data. That can be done by aggregate functions. example of aggregate functions is sum. If we have multiple numbers, if we put if we apply a sum function called sum, then it can returns only one value, right? Whatever, how many numbers entered, we expect only one value from that aggregate function. What about maximum? Then only one value, max number. Minimum, only one. What about median? What about mode? All those statistics. What about count? Let's say we have so many numbers. How many numbers? Then maybe it's 75 numbers or 100 numbers. Some average, that is also only one average, right? So those are the aggregate function. So we can, this SQL statements also provides aggregate functions. So to here, I want to aggregate credit. This credit needs to be aggregated, right? So a sum. How can they aggregate? Only if name is the same, right? How can you specify? Only if name is the same. How can you know which one can be in this summation, the computation? That can be the only if we group those rows by name. If we group by name, as far as there are same name in that group, we sum the credit numbers. Do you catch that issue? Right? If we group by name, then in that group of Adam, then whatever the credit numbers, we count them. Okay? So hit enter. Very nicely we have that, right? Or how many credits they are, how many the courses they are taking. Then we need to put here count, and then as as number of courses. Then it returns Adam has 2 courses registered, Peter has 2 courses registered, Chris has 1 course registered. Depending upon this aggregate function, count or sum, we'll have different the result very nicely, right? And also if you want to change this, rather than say sum open and close parenthesis credit, we can rename it like here. Count credit as number of courses. So that comes here. Excuse me. Right? So that is very handy aggregate function. Another thing, this guy gives me only the rows who are currently registered. But if we see here, David never registered in this semester. Can we include that, saying his credit is 0, or number of courses registered, that is also 0? Can we say that? We may need that, right? So we need to do, in order to do that, then we need to first here what happens here is that see here Adam and let's see, put here. Then we have Adam and Peter and credit numbers, right? I didn't put any aggregate function yet. How can we include here somebody never registered? That is called not just join, but auto join. I want to put the left, I want to include all the values on the left side. Right hand side, then shows whatever the number that is. So that is called left to join. So left hand side. So in this from close, we want to first from student and enroll should be left to join. So we call that left join enroll E. In this case, if it is a left to join, then we need to put their join condition. So s.cwid equals e.cwid. There's a left to join. The result of that left to join should be also left to join with the rest. So left to join with the C, and then we need to put here that should be on. I believe in this way. So if we hit enter, then what happens here? Adam has 3 credit. Another record says Adam is 3 credit. Peter 3 credit. Peter 3 credit. David null, because David didn't register. Chris 3 credits. This kind of result. See, if you compare these two side by side, these two SQL statements, the first statements, you simply all tables are joined together. The second SQL statement says, I want to put the left to join. So left tables, I want to include all the rows in the left tables. So result of that, also left join with the next table. We keep going that. When we use a left join operator, then this where clause comes right after that left join, say on. After on, we put that conditions, like here, on. Those two CWIDs are same, or on, those two CRN numbers are the same. All right. So far, so good. And then if you want to put aggregate function, then we can do aggregate function. Let's say credit, maybe sum. We put sum. Credit as register the credits. And then we need to put here group by name. Hit enter. Then it gives me name, registered credits, Adams 6 credits, Peter 6 credits, Dave null, Chris 3. All right. It's very, very useful, very, very convenient and powerful. Huh?
Can you move the terminal script a little bit? Oh, I can't see what's on the right side. Yeah. Oh, okay.
Not much. Simply enroll. Yeah. The next one, that is very, very, very tough ones. So if you do not understand, you don't need to worry about in this 505 levels. But I want to challenge you if you are capable of. List the students who do not register any courses. That is the extension of these statements, right? Let's see the result first. Name some as registered from students out left join and left join. Credit students left join. Oh, what would we have here? This is something needs to be here. So where close needs to be there. So instead of this, s.cwid is null. Yeah, from enrollment. If enrollment CWID is null, then yeah. Do you see the issue here? If we put here s.cwid, then s.cwid, of course, there is no null. But e.cwid, enrollment, where there is enrollment CWID is null, which is David does not register. Therefore, it returns like this. So what could be in this blank? That is here, where close and everything from here there. That comes into this. Okay. This is the end of the simple. This is not really simple. The level of SQL expression is not simple. The SQL statements that we covered today. It's a little bit sophisticated as well. But this much that we learn in this 505 class, although there are lots of other the interesting SQL statements may be available, but we will stop here for databases. So the component of database is done.